Hey, what's up guys? We have another Model S here, 2015, with again with HVIL issue. And I've been working with the customer since quite a while. So the car has been in three repair shops in the last few years, I think. And that HVIL is an intermittent problem. It comes and goes. Sometimes the car drives, sometimes it does not. So it's not really reliable and the customer is really frustrated. It even went to 2 Tesla dealerships and one shop in Sacramento, California. And we'll see if I can figure this one out. I would love to. And I've been preparing for this since a few weeks now. I built a specific voltage logger that I can hook up to the car and see where or when there's a problem in the HVIL loop. So if we dive here into the logs of service mode, we can see that the HVIL always pops up with a blind mate error. I have not seen that on the other cars. We'll see what triggers this one. I did not do any research on that one yet, but here the W008 is the typical alert that we get with HVIL fault. So what I plan to do is, I printed all these diagrams out from the Tesla website. What I plan to do is measure the voltage of the HVIL system at several locations. So, in case you don't know, the HVIL basically is a safety circuit that disables the high voltage system in case any of the high voltage connectors on the car are disconnected. So that starts here at the battery. The battery high voltage connector has like a contact. When this is unplugged, the circuits gets interrupted and the contactors in the battery shut down, and this is all computer controlled. There are 1, 2, 3, 4 resistors in series, each 60 ohms, and a voltage source in the battery. So that voltage, all of that is in series, and if any of these connectors marked with X here are disconnected, the system shuts down. So at this point we have no idea where this fault is, and that's actually the problem, because this is the back of the car and this is the front. So it could be anywhere in this area here. So what I plan to do is put 4 probes. We're gonna measure the voltage on 4 locations. One is here, right when it comes out of the battery. Then one time after the drive unit, the motor. And this here is the charger and the second charger. So we're gonna measure after that, before the DC to DC inverter that sits in the front. And we're gonna measure after the DC to DC inverter, before it goes back into the battery. So with that, I'm gonna have all the information to pinpoint in what location that HVIL fault is located. Well, thus far the theory. So now we're gonna start connecting my probes to X976. That baby is located under the seat right here. And I'm gonna go at pin 16 and 17. Older Model S models have it at 4 and 14, but the coloring is always yellow, black, and yellow red. So these 2 wires at pin 16 and 17, or 4 and 14 on the diagram, gonna be tapped into. And then we're gonna do the other connector, which sits in the front, X950, the other two probes, and that one sits right here on the driver's side, left A pillar, this connector, and we should have yellow, dark blue and yellow gray to tap into. And we're always gonna measure the voltage against ground, just to add that. So where's this again? The voltage is gonna be the highest up here, and then we have two resistors in series, so three. Well, only if there's option. Yeah, there's an optional charger. So we have 180 ohms in series, so the voltage is going to be much lower at this point. And there's no resistor in here, so the voltage here and here should be the same actually on X950, the connector in the front footwell. So these two locations should have the same voltage. This one should be the highest, this one the second highest. So here we have our two chargers and the big junction box here in the middle. This is the slave charger. It says it here. And here's this connector in question. X976, X950, no. X976. This one here, that's this connector, 10 pins, and here are the two wires we're gonna probe. The voltage should be the highest on pin 4, which is yellow-black. That's where the voltage comes right out of the battery pack. So let me get some probes and connect this thing. Okay, I got two probes connected, yellow black, yellow red. And I got a voltmeter here, negative to ground. And now black and yellow cable. That should be the full voltage, which appears to be 4.8 volts. And then after two 60 ohm resistors, we are down to 2.3, 2.4 volts. All right, so this concludes the probes for the back. Now we're gonna do the same thing in the front, the other connector. Okay, we're in the front footwell. I removed the trim here, and it should be this black connector. I think this is already one of the cables. It should be located. So I think we are looking at the front of the connector. So we have to turn the picture around. So these two should be on this side, looking from here. That would make sense. So I'm gonna cut open the tape here to have better access, and then we can connect the probes. Okay, as expected, our two wires are right in the position where they should be. This one here is the one coming from the back, out of the chargers, out of the slave charger. Then it goes into the yellow dark blue here. So it comes out of the slave charger and goes the yellow black here again, goes into the DC to DC converter and junction box and comes out as yellow gray and goes back into the battery pack here. So again, I don't expect any different voltage between the two. We're gonna measure that in a second. So yellow, dark blue is the first one I want to measure. I have my voltage meter hooked up to ground as before. see if I can get one good shot of that. And that should be like lower than the last reading we had. I need to write this also down. 1.2 volts coming from the battery, and .9 volts here. So there's a bit of a loss in the DC to DC. That's interesting. That shouldn't be the case. So maybe you already have a clue here. We'll see. So it's losing. I'm gonna write this down. 1.190 volts. And here it was 1.206. 1.206 volts. So I'm gonna take the same measurements again and write it down in the back just to make sure we have it recorded. Okay, at the back seat again, voltage probe connected to ground, and the yellow black wire 4.87 volts. 4.87 V. And take this, in case you're also working on that, take this as your reference, because currently the car is good. Now we go to this one here. .399, 2.4 volts. 2.4 volts. Okay. Now we come to the heart of this operation. That's the voltage logger I built based on Arduino ESP32 and a voltage interface and a little display. So I can power that thing up with a battery, USB battery supply. And should start. Power up. Yeah, I don't know if the display is visible on camera. Oh yeah. It's kind of rolling, not with the naked eye, but on camera. So it's showing 0 volts everywhere. And here are my voltage probes. 4 inputs. And this is ground. And then I can connect this through Wi-Fi to Home Assistant, and I can read out the voltages and it's logging it on a graph, on a chart. And with that, I can basically leave this running the whole night, and I can see if there was a interruption, and I can see where it was in the circuit. That should give us a good clue. All right, I'm about to hook this up, and I have these wires color-coded, so later on the graph I know which one is connected where. This is the wire color I also mentioned here. So the blue wire should be the first one in the chain, then comes yellow, red, and green. See, blue. Oh yeah, where's yellow? What the heck did I do? I guess I meant orange. Yeah, I meant orange. Anyway, connect this to here. and plug this into the yellow black. And we also have ground connected here, the circuit board. Okay, I got it running. It's reading 2 voltages now. That blue cable here was disconnected. And yeah, we have 4.77 and 2.32. Now we're gonna hook the remaining 2 to the front, and then we'll let that thing log. Okay, all 4 sensors are populated and show up at the display. I don't know if this is clear. And we're going right here to the front. And now we let that thing log and see where we have the drop. Okay, on my computer now, and here we have the data as expected. That's the blue cable, the first one in line, the voltage 4 point something. Second one is the yellow or orange, and that's the 2 in the front. These are at the same voltage, at least. Yeah, there's a slight difference. I think I can even see that if I click on here. Red 1.15, 1.14. Yeah, this is not precise enough. It's not like my voltmeter, my handheld. So what I want to see on this graph is just a complete interruption, which, yeah, something must happen when the car shuts down. So that's what I want to capture. So I let this thing log now, and we'll see what happens in the next day or 2. I can also comfortably read the data on my phone now. And yeah, according to the customer, it can sometimes, the car would run for a day or even 2 before causing an issue. So that's why I built this logger. And the car is currently still in service mode, so I'm gonna take it off and take it out of service mode. And I also have it in camp mode. I think I leave this on because I want to avoid that the car shuts down completely. That would entail that it also shuts down HVIL, to my opinion. So I want to see if I can replicate that HVIL problem in camp mode. All right. Why does it always switch on the freaking AC? Okay, so we'll log now. So the car shut itself down yesterday evening between 6:43, around here. And we can see that all voltages basically dropped to 0 right here at 6:42. Yeah. And then we still had some signals going up from, this is the blue cable connected, basically coming right out of the battery pack. And I, at the beginning, was quite hopeful that I already isolated the problem, because to me it looked like there was an interruption right after here. So that would indicate it would be between here and the charger. So we were getting the signal right here, coming out of the battery, but not on this end. So after the drive unit and the charger. And my first impulse was that we have an issue right in between here. Then I realized I can actually scroll in. And when I do that, and I scroll in really like down to a microsecond or something, I can see that all wires actually got an impulse. You can see clearly here. So there was no interruption in between. The only thing I noticed before was this blue spike, and all these were hidden behind it. So back to the drawing board. There's something else going on. And well, I think I'm gonna lock the car one more day and see what it does. But one more thing I found is this waveform right here in the healthy log. So we get closer and closer here. So the green line, we're now zoomed into between 1.3 volts and 1.4 volts, and the green cable, that's the one coming out of the DC to DC converter going back to the BMS, has this strange waveform here, always dropping by 0.01 volts, which that's the only one that has this. It shouldn't happen. This should be a straight line. So maybe that's the first thing I'm gonna look into. Bypass. And yesterday I measured and there was a voltage difference between the two cables. So maybe that's a good starting point. Who knows? Several days later now, I've been logging the behavior of the vehicle since 3 nights ago, and it basically repeats the same pattern over and over again. There's no consistency. Sometimes it runs normal like here, then we have a period like here it was 5 o'clock in the evening, like until 4 o'clock next day, where the car would not activate. And in that period here I tested the whole harness, all connections and the resistance according to the specs of Tesla. Everything seems fine here. In that time I actually bypassed the whole HVIL circuit and made a complete new circuit and played with different resistance ratios, and the voltage peaked up higher, or that might have been actually where the circuit was completely open, but this one here was with a different resistor. So what I did is I disconnected this wire here going back into the battery, and on this end I made a direct connection to up here where it comes out of the battery pack. It comes out of the battery here, goes to this area, and I bridged it over here. So all this was bypassed, and of course I had a 180 ohms resistor in that circuit to simulate the same resistance that we have in this circuit when it's all normal. So here the motor has 60 ohms, we have 60 ohms here in the charger. The second charger has another 60 ohm resistor, so that's 180 ohms, and the last one is in here in the battery pack. So again, I made a direct connection from up here to this cable, disconnected it here in the connector, and no change. Yeah, that was in this period here. The car still refused to start up. So that makes me thinking now if our problem is not really the harness. I think that we have a problem in the BMS, and I guess this behavior here might be quite unusual because it's doing that no matter if the screen is on or not, and doors or it's shut down. So to my opinion, it could be that this voltage actually should be steady, no matter if there's an interruption in the HVIL circuit or not. So I'm gonna try exactly that now on a healthy car. I disconnect the HVIL circuit, and I'm getting a voltage of about 8.75, what we had here when it was disconnected, but steady, just like here. And that would basically call out the BMS as being the problem, because I don't think these peaks here could be caused by a intermittent contact somewhere. There's no curve, or it would have a more gradual change in voltage, not peaks like that shooting up and then dropping off in 10 milliseconds. Yeah, and for that I have another P90 here. Make sure it's the same BMS as this customer car, and we'll try that. Okay, we got another P90 here, and we're going to measure the HVIL on this car, known good car, and we'll see what happens once we disconnect the HVIL. So this car has only one charger, the slave charger is missing, but we're tapping into the same yellow-green cable. Well, I think it's a different color code because this is a later model. The other car, it's yellow-black, but that cable goes into the BMS before any resistor, and we're getting 5.89 volts here. So now I'm going to disconnect HVIL and see if the voltage here stays constant, or if it's like spiking every once in a while. I should be able to activate or deactivate HVIL by removing this plug here. That's the plug that goes into the slave charger, and this here is just an extra loop to keep HVIL closed. It's a dummy. So now see what happens when I unplug this. Obviously car should shut down. Have to push this down here. Okay. Oh no, it also goes to 0. So it's doing something. I gotta connect the data logger, get a better picture. So as expected, we have HVIL alerts now. F008 and F036. Okay, so yeah, I was hoping the voltage would stay flat when disconnecting the HVIL loop on this known good car before I call the BMS defect on the other vehicle, on the customer vehicle. But it seems it's not that clear, because replacing that BMS is kind of a big deal. A lot of work. We have to drop the battery and open the lid. It's a good day of work. So anyway, I'm gonna connect the logger now to this thing, and we'll see what it does to have a baseline. Okay, got the logger connected to just one channel, and the HVIL is hooked up again just to see if it closes by itself. And actually it did not. I had to manually fire up the car by switching, going onto the brake pedal and putting it in D in order to stimulate the HVIL circuit to come back. So when I repeat the same thing again with the logger connected, okay, let's pull the dummy HVIL again. Here we go. Voltage dropped to 0. So now I want to see on the data logger what it's doing. So far, same behavior as the other car. One thing I noticed, the voltage is higher. So the other car was 4.68 volts. And this one is, but that's almost to spec. And this one is 5.8, so 1 volt higher than the customer's vehicle. But HVIL disconnected, the car will just randomly probe if the HVIL is closed or not. I was kind of expecting to see a constant voltage here. So now we're going to open the door and see if it peaks up. See if I can share this on camera. It's beeping, but no voltage spike. Interesting. Park assist, vehicle may not restart, we know that. But no spike. Wow. Okay, I'll let this run for a while and see what happens. So I just did a ohm measurement. I think I have a lead here, quite promising. When I take the gray yellow cable here that is going to the front of the car, to the DC to DC converter, third pin on the top. Right here. So when I did that, that loop goes through the front circuit, front HVIL circuit, through the high voltage junction box and the DC to DC inverter. When I measure the customer's car, I'm getting 60 ohms, but this one goes up to 130. And well, what this is, we're dealing with a P90D here, which has a front motor, and that motor has another resistor in series. So the customer's car had a battery swap. It was initially a 60 and they swapped a 90 battery into it. And I was figuring maybe that battery came out of a dual drive as well, and the BMS is expecting a higher resistance, and that's why it's acting up intermittently depending on the temperature, because resistors often change depending on the temp. So I put another 60 ohm resistor into the harness of the car. I will show you right now. Okay, so here's my resistor setup. I cut the return line going back into the battery to the BMS and put a 60 ohm resistor in series to basically get to the same total resistance as we have at the P90. And at the beginning it looked really promising. The car immediately fired up and ran for about half an hour, and then it started shutting down again. So all the excitement for nothing. Back to the drawing board, and I think it's time to drop the battery and get a replacement BMS. Here we have the actual data, just to show you what I've seen on the screen. So all this here is the car in the customer's car. So the BMS is pinging the HVIL circuit every 10 minutes or so. It's very inconsistent. You can see the time here between the pings varies, and the voltage is always about 4.68 volts. And this here is actually the other P90 car, and that voltage is 5.8 volts because of that extra 60 ohm resistor in the circuit. So that changes the whole math. And yeah, here's when I interrupted that circuit, the P90, it spiked up to 8.8 and then shut down. So interestingly, these testing spikes are at a much lower voltage at the P90. This one, and they're always a different voltage. At the customer's car, they're always the same, exactly the same. But at the known good car, they're different. So that first test peak was 0.09 volts. This one was 1.53. Then it did one at 5.18. Another one at 0.59, 0.76, and 1.46. So around this time here, I added the 60 ohm resistor to the customer's car, and this was the first loop, I think. I forget. Oh no, this was still the P90. This here is the customer's car with the resistor connected, and you can see the voltage is almost the same as the P90. 5.82 and 5.8 at this one here. But yeah, the car immediately fired up and we have all the circuits good, and it lasted only 20 minutes, yeah, before it shut down again. And since then it's basically doing that. So I switched that 60 ohm resistor to a 10 ohm, and that brought the voltage a little bit down to 4.86 volts versus 4.68, so 0.2 volts more. I just wanted to see if maybe we were at a too high level here. But yeah, it's the same behavior we had all these days. So it's pinging and pinging, and then there's a long time nothing, and I think these last 3 pings here are when I opened the door and played with the car. But HVIL, I mean the system is not engaging. It's the same game. It will do randomly, come on and off. So it's time to call the BMS, take it from there. We're gonna order it on eBay. So here's the BMS we're gonna buy on eBay. Once that's here, I'm gonna drop the battery and try that thing. Hope that's it.